all, let us discuss about 2 points in this video. One is what is net antenna in PCB, and second one, what is ground pore in PCB. So starting with the net antenna, let us assume a scenario where we have a small component on PCB. Okay, so we generally route this with a trace. Now let us assume I connected this to some other component here, okay, and this component, this trace which we are talking here is open. So these cases where a trace or a small copper which is open and it is not connected anywhere. When we say copper, it could be a trace again, or a arc which is not connected anywhere and it is left open. So this kind of scenarios, what happens is, why it is called a net antenna is because these traces can act as antennas and hence radiate the signals out. So radiation again depends on the frequency. It has to match the quarter wavelength thing which we talk in antennas, but still an open-ended trace is always a dangerous one, and we are not sure when the radiation happens, right? Because we directly don't probe on PCB. So when we put it in live during our bench testing, we may not see an issue, but when it goes onto the field and it is used, it might cause a radiation and hence interference. So these kind of open-ended traces should be eliminated. So now this generally will have the PCB layout tools will have properties, or we call the constraints, where the net antenna, the length of this net antenna will be mentioned. So generally we mention it as 0, so that anything beyond this 0 mils, if there is a small trace that comes beyond this 0 mils, it is considered as a net antenna and it will be thrown as a warning. Now that is one scenario where there is open-ended track. Now let us assume this is a top layer, okay, and if you see, this is the top view of a top layer, and if you see the side view, it will be this way, okay, and then there is one more layer. Example, there is one more layer, and there is, let us assume, a 4-layer stack up. So this is a top layer, this is a ground layer, or if you want to use it as a signal layer, you can use it. And let's assume a scenario where this is a ground layer again, or a signal layer, and or a power layer for that case, and then this is again the bottom layer, okay. So top layer, ground, power, and bottom. So this is a reference plane, this is a reference plane. Now what has happened is, let us assume a scenario where there are two different power planes. One is 3.3 example, and one is 5 volts. Okay, so that means there is a split between these two planes here. Now let us assume a signal that is coming this way here. Okay, now and then it is routed on the bottom layer. When it is routed, the return current, so the signal is going this way, and then the return path will see this. So in this scenario, you see that there is a plane split. So what we do is, as we discussed initially, we will have vias, okay, right, to a ground plane, and then this via extends till the top layer. So you will have a ground plane via to ground plane. So the connectivity is only till ground plane, and this ground, so if you see on the top, there will be two wires that will be coming this way. Now on the top layer, these two wires, when we are seeing this way, if these wires are not connected with any copper and these are left open, what happens is from the bottom definitely we'll have a ground, and then they are connected to the ground plane in the second layer, which is a ground layer, and then in the top layer these are left open. So this is also a net antenna condition, which is considered by the PCB layout tool. Now in this scenario, what we have to do is on the top layer, similar to the bottom layer, we should have a small ground pore which will combine these two, and this should be a ground plane. Small ground pore is required. Otherwise, these two wires are treated as antennas, and it's not just a trace as we mentioned here. A wire like this is also treated as a antenna, which is called a net antenna. So now we have talked about net antenna. We are also talking about small copper pores also. So this copper pore, right now what we did is basically a ground pore, because we have grounded that. Now this ground pore, or generally we call it a copper pore on the PCB. Let us assume I have traces this way. They'll be straight, or you might have routed this way. So now let us assume I have something like this. Okay, so and if I have some IC here, example, the space between these two traces, generally the PCB designers, what they do is they fill with a small copper area. This is called a copper pore. So this copper pore helps for in different ways. The major thing is it helps to isolate these two traces, and this copper pore can be either connected to a power plane or a ground plane. Generally we connect it to a ground plane because there is a stable reference. Yeah, stable reference which is treated as a stable reference in the PCBs. Now let us assume I leave this copper pore this way and I don't ground this. That means a plain copper pore which is not connected anywhere. This might not be a problem with low speed designs, like a small microcontroller based designs, but when we go to high speed designs, having such copper pore could lead to a catastrophic cases. Like what can happen is this trace can couple signal onto this because of this magnetic field, and then again this can couple onto this. So that means a cross coupling condition can happen, or this trace can act as antenna and it can radiate. So ground pore is completely different in a low speed PCB and a high speed PCB. Low speed PCB, if you do a ground pore, there should not be any issue. Even if it is a open area, and if if you don't have a wire to ground also, there is no issue. You can leave it open because these are low frequency signals, and they radiating, or they coupling to other trace because of the capacitive effect is very less. But if there is a high frequency signal, because of this capacitance between this and the trace, this pore and the trace, the signal gets coupled. So we have to be very careful, and we have to ground this using wires at some points. So hope I am clear here. So these two things are very important for the PCB designers to understand. Please comment if you have any questions on this. Please like and subscribe our channel. I would like to thank one of the PCB layout engineer who suggested me to explain it this way rather than a board. He said this could be the easiest way where people will understand. Thanks for that suggestion. Hope you liked the video. Thank you.